Happy Friday. This is our last video out of chapter 3 or module 3. We do have 1.5 sections in module 4 which you don't have, but I'm going to make my own worksheet for that and we'll go over that not next week but the last week of school. So make sure you check out the announcement on Blackboard. Just some notes to yourself. A week from today will be our last exam. I'm not going to make a video for Monday or Wednesday, so what my expectations are is Monday you will work on the OWOW and try to get caught up a little bit on Monday with the material. We have a bunch of sections due next week, so Mondays would be like a work day for us. And then Wednesday is a review day for us, so there won't be a video that day. And then Friday's the test. So next week is just kind of a big catch-up week for us. So no new material next week, which is good. Yay! And then the next week is our last week. So we're really getting down to the wire. It's kind of exciting. All right. So last section that we're going to cover for the last exam is section 3.8. It's on page 405 of your packet. And I'm going to just jump right into it, okay? Let's just look at a little bit of this first example. It talks about Paula who goes to school and she needs to make a decision whether it would be cheaper to carpool with a friend or if she should buy a bus pass. All right? So let's look at the formula and see if we can make some sense of it. So it says the cost for carpooling per week is in terms of the unknown variable m. Do you see that? And m is the total miles driven one way. All right? So they determined that it's going to cost about 22 cents per mile. So that's where that comes from. And about 8.2 cents per mile. So 8 cents would be 0.08 in pennies, like in change. $0.08 or $0.082 because everything's going to be in terms of dollars instead of pennies. And then there's a $25 parking fee per week. That seems so steep, right? I guess they must live in the city. So there we go. So it says she'd have to pay for half of the cost because she's going to split it with her friend, and it's based on the miles that they drive and the parking fee to park on campus. So the 1/2 means they're sharing, they're splitting the cost in half. This is the 8 cents per mile, the 22 cents per mile, and then the 25 flat rate to park at the school. All right. All right, so hopefully that makes a little bit of sense. And then we're going to have to write this formula down to be able to mess around with it the next problem. So I'm going to write the formula down for you. I wrote it on a separate sheet here. It says find the total weekly carpooling cost if the commute to school is 7 miles one way and Paula goes to school 3 times a week. So here's the formula that was on the previous page so you guys don't have to keep flipping back and forth. So pull out your calculators. I wish we were in our groups because this is a nice group one. And figure out what it would cost Paula if she was carpooling with her friend, if Paula has to go to school like Monday, Wednesday, Friday, 3 times a week, and it's 7 miles one way. Okay. So let's see. If it's 7 miles each way, then it would be 14 miles round trip, right? For one day. And she's going to school 3 times, so that's going to be times 3. So it looks like she's going to be traveling 42 miles for the week. Does that make sense? So we need to put 42 into this equation, and that's going to tell us what it's going to cost her. Okay, So 1/2, what it's going to cost her for the week. 0.082 times 42 miles plus 0.22 times 42 miles plus 25. So it looks like it's going to cost her $18.84. Okay? Now, I'm not going to play with this next problem. They did not give us enough room for this. All I want you to answer is if a weekly bus pass costs $22, and this is really what her schedule is, what would be cheaper? So right now, it would be cheaper for her to carpool. It would be cheaper for Paula to carpool. But the only bad thing is if it's not her car, right? She's only going 3 times a week then. Well, I won't even play with it. But so right now it would be cheaper for Paula to carpool. But if she has to add another day to her schedule, or she's going 4 or 5 days a week, then we really need to readjust because this is pretty close. Here, I'm curious. So let's just say she has to go 5 days a week. You don't need to write this down. I'm just curious. So it would be 14 times 5. So that means she'd be traveling 70 miles. I wonder how much it would cost her if she had to go every single day. Very curious. What did we say? 70 miles? Oops. Times 70 plus, you don't need to write this down, just humor me because I'm curious. So if she had to go every day, then it would be cheaper for her to do the bus pass. I just threw in 2 more days. I said she's going to travel 14 miles times 5, which is 5 days a week, so 70 miles. So if she was going every day, then it would be cheaper for her to just buy the bus pass. All right, interesting. Okay, so this is the formula we were looking at before. Do you remember it was for blood alcohol content, and they've already filled in a few pieces. So they simplified it down. They already took into consideration that it's a male who weighs 190 pounds. So they did a little bit of the back work for us and said this is what their blood alcohol content would be depending on the number of drinks and how much time has gone by. So there must have been a crime scene, and a forensic scientist is going to use this equation at the time of the accident to determine how many drinks somebody had. Okay, so let's look at this. So let's just say, in this case, the time and the blood alcohol content are known from the police report. So the crime lab uses this equation to estimate the number of drinks. So we know that the blood alcohol content is 0.09, so we can fill that in there. 0.09, that's pretty high. All right, and we know that the time was 2 hours from that right there. And we need to figure out the number of drinks that this person had. All right, well, let's just multiply that out, make that little bit simpler. You guys get negative 0.03. Is that okay? So 0.09 equals negative 0.03 plus 0.022n. And by the way, all this section is just manipulating different equations. That's all it is. All right, so I always bubble the unknown and know once I get that by itself, the last thing I'm going to do is undive. It's all about is divide. It's all about undoing operations. And a lot of people say, well, you think about PEMDAS and it's PEMDAS in reverse. So if I knew what n was, I would multiply first, and then I would subtract 0.03. So people say solving equations, you undo that. So the first thing I'm going to do is take care of that, and then take care of the 0.022. I always just like to bubble this and say, okay, we got to get this by itself, and then we'll undo the 0.022. So how do you undo a negative? To undo a negative, you add. And what you do to one side, you have to do to the other. So I'll bring it over here. So 0.09 plus 0.03. Did you guys get 0.12? And that's going to equal what's left over, 0.022n. So to get n by itself, what do we do to undo multiplication? To undo multiplication, we divide. So it looks like n is going to be 0.12 divided by 0.022. Looks like around 5.45 drinks. So they had about 5.5 drinks, and then apparently started to drive, and that's why an accident happened, because they were way above the legal limit for New York. All right, so this is definitely a question that they're going to have on the final. Okay, I'm letting you know right now. They have always had something like this. So what they want you to do is they're going to give you an equation like this one. I'm going to write it out again. And they're going to, so this is b equals something in terms of n and t. They're going to ask you to just solve for n. So get n equals something in terms of b and t. It's definitely going to be on the final. So let's just look. They're asking us to solve for n. So they say solve for n in terms of b and t. In other words, get n so that it's all by itself on one side of the equation. All right, so it's kind of like what we were just doing. So look, we need to get this by itself, and then we divide. So to get that by itself, I need to undo this. It's a negative, so to undo adding a negative term is adding a positive term. So what you do to one side of that equation, you've got to do to the other, right? Okay. So this is going to give us b plus 0.015t. And then on this side, we'll have 0.022n. And then just like we did before, we're going to divide. Okay, 0.022. So it looks like another way to write this equation is b plus 0.015t all over 0.022. Nothing hard. So here, let's just practice this again. So let's look at what we just did. So b was 0.09. The time that went by was 2. And then we divide that by 0.222. Right? So it's kind of nice now, right? If I'm given a blood alcohol content and the time that's gone by, I can pretty easily figure out the number of drinks. So they said, try using this now for a different problem. So here's your formula. Okay, so they said now use this if the blood wow, it's really high. If the blood alcohol content is 0.17 and the time is 1.5, go ahead and figure out how many drinks the person had. Just take a minute, pause the video, pop those into your calculator, and see what you get. It's going to be quite a few more. That's a really high blood alcohol content. Okay. So we're going to put 0.17 in for B. For T, I'm going to put 1.5 and then 0.022. Right. I'm going to use the fraction key in my calculator. I really like that fraction key. So there's my fraction. Okay. plus 0.015 times 1.5. So there's the upstairs. And then downstairs is 0.022. So it looks like this person had about 8.75 drinks. That is a lot of drinks. And that's why their blood alcohol content was so high. So that's kind of interesting, right? I think that's interesting. All right. So anyway, these formulas are cool. So 2 different formulas. That's all this whole section is. It's just manipulating some formulas. All right. So let's look at this. These deal with area and volume. So this first one's an area problem. So we're volunteering for a nonprofit organization interested in women's issues, and this is our logo. This is what it's going to look like. 3 squares. It's 3 identical squares arranged as follows. So the organization wants to make banners of different sizes. So they said, what would the equation be to find the total area of the logo based on the length of one of the sides? Well, since these are squares of the same size, if we label one side X, then every side gets labeled X, right? And we know area is length times width. So does it make sense that area would be X times X, or X squared? Now that's one of the boxes, and now we have 3 of them. So the area would be 3 of these X squareds. That's X squared, that area is X squared, and that area is X squared. Does that make sense? So now they say, your organization is sponsoring a walkathon to raise funds for breast cancer research. I think this is an interesting idea. You want to create this logo in the middle of the racetrack with bras that have been collected at multiple drop-off sites around the city. So we estimate that we have 1,500 square feet of bras that have been donated. So like if we laid them out, it would cover 1,500 square feet of bras. So that's the area. So this is an area. So they want to know how would we rearrange these so that it would make our logo, like what would be the length of each side then of our square. So we know the area formula that we just calculated upstairs, and we know the total area is going to be 1,500. So how do I get the X squared by itself? Well, what's hanging out with it? Right, the 3's hanging out with it, so I would divide both sides by 3. Okay, so 1,500 divided by 3 looks like each square is going to have an area 500. Now, an area 500. Now, we did this. Do you remember we talked about how to undo a square? And by this, I mean this square right here. How do we undo a square? Do you remember I told you guys that there's a square root key on our calculator? And that's how you can undo a square sign. The square and the square root cancel each other out, and then we're going to pop that into our calculator. Now, the calculator is going to give you something weird. Remember, we're going to have to hit the change key if we need to. So the square key on this calculator is right above the X squared button. Do you see that? It's in green, so we have to hit the green button first. And then I get something really weird. Like they're going to say round it to like the nearest tenth. Well, that's like weird. So hit the change key. Remember, change is right above enter, and that's going to change the way it gives your answer. So it looks like X is going to be about 22.4 feet. So each square is going to be 22.4 feet by 22.4 feet of bras. Does that make sense? Undoing a square, because sometimes we have to solve equations with squares in them, you're going to take the square root once that squared term is all by itself. All right, so that's a technique that we have to do down here as well. Except it's a cube, and that's what I want to do this so I could show it to you. Okay, we're going to be messing with a cube root instead of a square root. So, an artist wants to create a sculpture, a sphere. So a sphere is like a basketball. So they want to create a sculpture in the shape of a basketball. That's what a sphere looks like. Okay? And the radius, right, starts at the center of the sphere and goes to the edge. That's the radius. So this is a volume of a sphere, the formula for volume. You don't have to memorize any of these. They'll be given to you on the final. So when the artist ordered their clay, a big rectangular slab of clay showed up in the mail. So the rectangular slab of clay looked like this, that showed up in the mail, and it was 6 inches by 4 inches by 2 inches. So the volume of a shoebox or rectangular prism like this is length times width times height. So pull out your calculator, do the length times width times height. You should get 48 cubic inches. So this is the volume that the artist is going to use. So they're going to take that rectangle and start forming it and smushing it together so that it'll resemble a ball. But the volume is the same. It's the same amount of clay here that's going to be here. So the volume will be the same. The shape's just going to be different. So it says if we have 48 cubic inches of clay, what's going to be the radius of my earth? So 48 is the volume, and this equals to 4/3 pi r cubed. And they want to know the radius. Well, I can get rid of the 4/3 and the pi by dividing both sides, right? We can get the r by itself. We just need to divide both sides by 4/3 pi. Pull out our calculator. Right? Those cancel and those cancel. Look, this isn't a big deal. Put in our calculator. It's a fraction. On the top we have 48. On the bottom I have another fraction. That's 4/3. And next to it is pi. There's my pi key. You see that? That's what it looks like. 48 on the top, 4/3 pi on the bottom. Okay, so 11.459. I'm just going to keep that into my calculator. So 11.459, I'll keep writing it, 1559. Okay. Make sure you get that on your calculator as well. 11.4591559. 4591559. All right, but that's equal to r cubed. So if taking square root gets rid of a square, would it make sense then taking the cube root of both sides will get rid of the cubed? Interesting. Okay. So how do we find the cube root on here? All right. The cube root key is right above the caret key. Do you see the caret key? It's in green, so you have to hit the green key first. But we need to tell the calculator that we want to take the cube root. So you have to hit the 3 first, and then that key. So do you see how it just pops right up there to the cube root? I'll do it again. We're going to take the cube root, so hit the 3 first, and then the root buttons are right above that little caret key. and then I'm going to put my big number in there. So 2.25-ish is what the radius is going to be of my Earth. Be teeny, like just a little teeny thing, 2.25 inches. So the radius, let's get this down, the radius is 2.25 inches. So now you can solve for variables that have been raised to powers. And there's one like that in the OCE. All right, so speaking of which, let's check it out. So that's it. So all this section was just observing different types of equations and being able to manipulate them. Okay? Cross off 2 as always. I don't usually teach solving equations with order of operations, so we're going to do number 1 together. I always just circle the term with the unknown in it and undo everything else. But they say the order of operations is used in determining the order of steps in solving an equation. I typically don't teach it that way, but this is one way you can solve equations. So I'm going to tell you what that answer is, because that's typically not how I solve equations. All right. So cross off number 1, we just did number 1, cross off 2. You can do 3. It's just solving equations, right? And I want you to notice that this is technically, right, a fraction equaling a fraction, so you can cross multiply if you want for this one. That's my little hint. All right, so that shouldn't be too hard. So for number 4 is, all they're asking you to do is, instead of having f equal something, they want you to solve the equation for c. So you're going to subtract 32 and then get rid of the 9/5. So you want to get c by itself. So just solve for c. And then same with this. Here's the equation, and they want you to solve this equation for r. Solve for r, right? So like what I always do, I would circle this and say, okay, we've got to get this by itself, and then our last step would be to divide. So that shouldn't be too terrible, right? That shouldn't be too hard. I want you to cross off number 5. Okay, cross off number 5, and then only because they talk about spreadsheets and we're not messing with that stuff. So cross off number 5, and then we just have 6 and 7 left. So I'm going to give you a hint for this one. Remember, I'll give you a hint. Remember to undo a square term, you need to take the square root of both sides of the equation, okay? And then this is just an interesting little problem that you can read. It makes some sense just to read it and answer that question. And then the only other thing is just number 7, and it's talking about water footprint. Okay, so the problems are on this side, and I don't think I had any troubles with that. I didn't think you'd be worried about that. So for do part C, they want you to solve this proportion out. So it says calculate China's water footprint if it used the same rate as India. So basically you're just going to solve part B. Okay? And that's it. Woohoo! So we are done with Module 3. So let me know if you guys have any questions. I should be around most of the weekend, so feel free to ask me questions if you have any concerns, feel free to Zoom. I know I've been pretty busy, but this weekend should be pretty slow, so feel free to Zoom me anytime. All right, take care, everyone, and I will see you, if not this weekend, then definitely a week from today on your exam. So I'll send out times in an email that I'll have you all respond to, because I'll give you the choice to take it during your exam, like when your class is, or I'll give you an evening option as well in case you're working during the day. All right, we will hopefully see you this weekend. If not, I will see you a week from today. All right, take care. Bye-bye. Oh, I know I said bye, but I was looking at this. So before I say goodbye again, this is not solving for B. So don't worry about part C. So I'm glad I took a look at that. So just cross off part C. We're not going to worry about it. Bloop, bloop, bloop. Cross that off. It's not solving for B, and it's complicated. So ignore it. So just do A and B for that one. All right, guys, this is for real. I'll see you soon. Take care.